All right, so yeah, that was the nice intro. See, it's been a long pandemic. So let's just jump in. I'm going to share my screen again. Um, you couldn't. Oh, you couldn't hear. Oh no 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 no. Okay. All right. So here is a sample project. So I decided to do something in the mobile area, just to keep things kind of interesting. So a lot of mobile applications, like Android or iOS apps, have many API services behind them. I mean, there are things like React Native, and of course, like Android Studio and or Android and iOS and Swift. Um, but you can kind of think of them as a bunch of services behind like a UI. So like that's kind of where I'm going to start today. So let's see what this application is. This is a very simple, very rudimentary kind of e-commerce app for Swag Labs. It's an online store where you can purchase items. So let's see what this looks like. So I'm going to build this API, or sorry, I'm going to build this APK. And then actually, so once this is built, let's go over to Sauce Labs. And I've already uploaded this to my Sauce Labs account. So the first thing I want to kind of walk through is an example of where you can replace an end-to-end test or a UI test with something much simpler. Like you can actually go even lower than the API, and you can replace an end-to-end test with a unit test. So instead of invoking services, instead of invoking the entire application for an end-to-end or a UI test, or invoking the entire UI layer, you just need the application code. So you can just test at the unit layer. So let's take a look at what that might look like. So here's an application. I've just uploaded it recently. This is a standard Android application. And I'm just going to open it up on Sauce. Well, let's open it up on Google Pixel 4. Why not? So this will be the application we're working with today. So this app is open source. You can build it using the GitHub link that I shared, but there's also other links as well. So here's my demo app, Swag Labs. You can get all different sorts of items, but there is some interesting behaviors that are kind of in here. So for example, if I add, let's say I want to add this backpack, I add it to my cart, and we'll see here that, oh, I've added something to my cart, no problem. So actually I'm going to reset the app state. Reset app state. Let's see. So now if I go back to my items, I go back to catalog. So when I add a Sauce Labs Bolt t-shirt, however, I get something a little different. If I add to cart, I get a 10. So even though I click and I've added 1, I get a 10 here. So this is a bug. This is obviously a bug. There could be many reasons for why this bug is happening. From my experience, this is the kind of bug that you might find if you're doing some sort of UI automation, right? You click the add cart, you expect to get 1, you check the cart, and you end up getting 10. So actually, I'm just going to zoom in here. Let's see if I can zoom in. I can't zoom in my screen. But anyway, you can check. Oh, it's getting kind of loose. Okay. There is a 10 there. Oh, this is getting all fuzzy. So there's a 10 there. So this is a bug. And so you could write some kind of end-to-end test using Selenium, using Appium, in this case, using Appium, and to just verify and get that cart item and cart text. But you often, like, that might be too heavy duty. That might be too much to go get into. You have to invoke the entire app. You have to open it up. You have to find an environment. You have to find, in this case, you have to find a device. Is it a phone? Is it the right operating system? Do you install it? Like, are there other issues? When you could just verify, like, you know, when I want to verify this behavior, that when I add 1 item to this cart, I get 1 item back. So So that can be done. Okay, we'll leave all that. So that can be done at the unit level. You don't need the entire application. You don't need anything like that. So what I've done is I've gone ahead and I've added. So this is a single unit test. So I've added 2 cases. And so these cases, what I've done is I've gone into the actual source application code. And I've found, okay, this is the product detail fragment. This is where you handle the product details of which product are you selecting, which product is it specifically, details like what's the name of the product, if there's a color associated, if there's a size associated, if it's a t-shirt or something, you get all those details here. So I was able to dig in and find where exactly this logic lived. So I've added this test, add one item to cart. So basically I get a product. I set like some kind of title to an item. This is required. And then I go forward and then I just write this very simple test. So I set up a product. I add one product to cart. I count the items. If I have one item in my cart, I should get one item back. So I'm going to run this test. And as you'll see, this is running your tests. This is running your tests without invoking any services, without invoking any APIs. I don't have to upload the app. I don't have to create an APK or an IPA or some kind of release. I don't have to push to a server. I can just verify. So this works. So this works. And adding one item to my cart generically does function the way that I expect it to. So the bug that I encountered was in this scenario where I'm specifically adding this Sauce Labs Bold t-shirt. So again, the source of the bug is irrelevant. All I know is when I click and I try to add one of these Sauce Bolt t-shirts to my cart, I end up getting 10. So there's buggy behavior. Something is wrong with the app. Or something is unexpected with the app, I guess I should say. So, so I can write a test. So using this idea, digging into the source and just trying to find where, and actually we can take a look at that. So if I go to this product detail, go here. Oh, actually, I'm going to go to this definition. There we go. So as we can see here, this is where this logic lives. And I go through and it turns out, oh, sorry, I have to go down a little farther than I thought. So count items in cart. But it turns out here is where the bug lives. So when I actually get this Sauce Labs Bolt t-shirt here, it sets the number. Now why this is here, it could be anything. It could be maybe there was a promotion a while ago on these shirts, and if you buy one, you get 10 for free. Something, or like 9 for free. That maybe there was some kind of crazy promotion there for something. Maybe this was a typo. Maybe it was someone was like, oh, I have to handle the special case. This number should be 1 or 2, but it actually put 10. Could be anything. Could be anything. But we found where this bug is. So now we can test this. We can test this behavior by going back to this unit test, and just to kind of walk through the structure of this test a little bit, because this is an Android project. This is all in Java. So I'm using Android Studio. There is a free version of Android Studio out there. I think, oh yeah, no, there's free, and there's also a free version of IntelliJ Community Edition. So if you like IntelliJ, it's basically the same IDE. Android Studio comes with some nice functionality for testing Android applications, or kind of not just testing, but also like just developing general applications. So, and I'm just using JUnit. So let's take a look at our imports. Like this is it. I'm using some internal, I'm getting those internal classes, I guess these product detail, these fragments that are actually being used in this Android application. And I'm importing JUnit. So very, very lightweight. Again, like I'm not testing any APIs yet. I'm not testing using the full application. I don't need to build anything. other than the source code. So all I'm doing is I'm just verifying, does this behavior do the way what I expect it to? Now, now if I run this test, here's the thing. Bear with me. The demo gods were not friendly to me this morning. This test passes. Now this test should fail. This should fail because I'm trying to verify, if I put one Sauce Labs Bolt t-shirt in my cart, I should expect one, but in the application, I'm actually getting 10. So, the idea is there. I can write this unit test to kind of get things started. So I can do that. And it should fail because I'm trying to verify it's 1 and I should get 10 for reasons unknown, copy paste error on my behalf. But if you go back, but you should be able to kind of, look at this and verify and walk through this unit test, adding item to cart with this buggy behavior. Let's see where to go. You should be able to verify that, like, you can find the bug, reproduce the bug, running your unit tests. And again, unit tests are really great because they're lightweight. You can run them, like, for example, adding, if I decide to run these tests again, they take like a couple seconds. I mean, most of the time is really just building out the Java. So they run, everything's happy. And I should be able to get to the bottom of this bug. So repurposing your end-to-end tests as unit tests are one way you can kind of think through your app. If you have access to your application source code, the production code for your application, and you find a bug and you think to yourself, maybe I don't need the full application for this. Maybe I don't need any of the back-end services for this. Start thinking at the unit level. Like, can I? And I've seen this in real life. This example is actually based on a situation that I ran into many years ago now. Great situation. So there was a bug in an app that I was working on. If you added, there was a list of items and you could add to items, or it was a list of accounts or something. If you added 127, you were fine. If you added 128, so once you went from 127 to 128, the application crashed, the front end broke down, everything was a mess. The reason was nothing sophisticated. The back end was Java, and I believe the front end was Java as well. And someone defined list of items as a short integer. So short integers can't go higher than 127 in Java anyway. So we try to go higher than that, and strange things start to happen, and the application breaks. So that was revealed in end-to-end testing and revealed in exploratory testing. But the fix to verify it, you didn't have to write this big long Selenium test. This was a web application at the time. You could just write a unit test like that. So this is just to kind of get in the spirit of like trying to find ways, trying to find how you can get into your application in order to test things out. So let me stop sharing for now. Let's see. Yeah, any questions or comments on that? Okay, how many people? All right, just taking a quick look. Okay, great. Yeah, so definitely, and again, definitely, take a look at that application. All of this should be in the GitHub link that I sent. You can definitely pull it down, open up an Android Studio. Should all work. You can be able to do this as well, kind of walking along. So let's. So I wonder if. Oh, I bet I know what the problem is. So let's take a little break and have a little intro of our application here. You know, a little video just for fun. So let's do that. All right, so I'm going to share entire screen. Everything goes away. And yeah, I've been told that you can't hear sound, so I'll try to narrate this as best I can.
Now, a key piece of any test framework.
So a piece of any test framework is your API.
This guy is really helpful, and if
Yeah.
you keep it in good shape, it's going to last you forever, and it's going to help you a lot in your test framework. So let's take a look at what we can do with the API in our UI automation.
All right, so basically, you know, pointing to like all the different parts in your application. One thing is API. So your API, you're going to be able to get a lot of mileage out of. Very helpful layer. I always say like the most difficult part of API testing or working with APIs is actually building out a good solid API, whether that's a RESTful API, whether it's a SOAP-based API, something like that. That's always the hard part. Once you have that layer that you can access, life gets a lot better. So let's take a look. All right. Okay, so let's go back. Let's go back to Sauce, and let's just take a look at our application. Oh, sorry. Oh, no, that's not what I want. Sorry, bear with me, y'all. It's a little rough. Okay, so let's open up this device again. All right, Pixel 5 sounds good. All right, so now let's walk through a little bit of the workflow. So if you worked with like an e-commerce app or any sort of like online store type application, there are a lot of services that you might use in the back end, some of which could be owned by your team and your org. Some of them could be owned by third parties. So if you hook into like a PayPal API or like something like a Shopify or something like that. So in this app, we have kind of a basic service like that as well. So I'm going to try to buy this backpack. Right, so I go to my cart and I'm going to proceed to checkout. And I'm going to use my username here. And password is, I think, 10, 20, 30, 40. So, and these credentials come from, I'm going to close down this virtual keyboard. So these come from here. So helpfully provided in this demo app, again, to kind of show you what you can do. So I'm going to log in. Okay, I'm going to put my name in here, Josh Grant. I live in Canada Street, maybe 1 Canada Street. I am coming to you from lovely Toronto, Ontario. I didn't ask everybody where they're from, actually. I guess it's almost like I'm worried about time here. Okay, and so let's say I want to, I'm coming from Toronto, Ontario, and my zip code is something. We don't have zip codes up here, but that's fine. And I'm in Canada. Okay, so I put in my address, I put a payment. Now this is where it gets interesting. So let's say, so in this application, there's a very rudimentary credit card service. And so this credit card service does some validation of your credit card. So as you can see from the application, my demo app only accepts Visa and MasterCard. It doesn't accept other credit cards. It's a choice of the vendor, okay? So for example, if I'm putting my name here, Josh Grant, let's say that's on my credit card. Let's say I put in a credit card number, and I think, oh, I'm going to use my American Express card, which I think starts with 6. I don't know. So I'm going to put in some credit card number starting with a 6. Okay, like this. And I have an expiration date. Maybe it's 01/29. I don't know. I have a long running credit card. And I have a security code. Let's just say 123. So let's say I try to review my order. Oh, I see. Okay. So let's just do this. I'm just going to follow some of these defaults. Row, Cornwall. And United Kingdom. Okay. All right. So I go to payment. So now if I try to put in, like, let's say I go back to my American Express card, it's got like some kind of numbers in here. Okay. Close this down. If I go to here, let's say I press enter. Oh dear. Well, this credit card should be invalidated because I have a backend service. Now this backend service is found here. So for example, let's say, so this backend service, again, very rudimentary. It's only got a few endpoints. One is that you can validate a card number. And one is that you can get credit card details, right? So maybe this service provides you valid test data that you can use in your credit card testing. So let's see what this does. So if I put in a card number here, oh, and this is available, so you can definitely take this. I'm going to go back to here. Put this in the chat. Oh, and actually, I'm going to do this. So this is docs, I think. So this is a service that I just set up. It's hosted. It's very rudimentary. The point is, it's kind of representative of what like either like a third party or even a different like service from a different team. If you're a very large company, you might have a different team. So it's something that is up and available to you, but you might not know the details of it, or you might have some of the details of it. So this is kind of a flavor of API testing, where you're given an API, you're given a service, you're given this open API kind of interface, formerly known as Swagger. So this is a really great tool. If you do anything related to service testing or API testing, I strongly recommend to see, like, ask your developers or ask whoever is working with you, or whoever is developing your API. Do you have an open API page, documentation? Do you have Swagger? Just because it's really great to like interact with and kind of learn about how to work with your API. So here's this service that's being used. So I'm going to try it out. So for example, if I put in my original number here, something like that. So this starts with a 6. So if I execute it back, I get bad request. Card not accepted. Must be MasterCard or Visa only. So if American Express starts with a 6, I can't use it. However, let's say I try to use something that's like a MasterCard. I happen to know that MasterCard numbers start with 5. And I do this, I add some digits, I execute. Oh, insufficient length. So again, there's another check that is done here. So for example, let's say I have my credit card number and I think, oh, I just need to put in like the first few digits. That's not enough. I'm going to need more and more digits. I'm going to need at least 4 times 4, 16 digits in my card. Some cards could have more, but this service does check that I'm actually that I actually have at least 16 digits in the credit card I'm trying to use. And there's some requests here. Get a bad request back. So let's do this. 0, 0, 0, 9, 9, 9, 9, 9. Okay, this should work. I execute, and I get back accepted. So credit card starts with 5. So I get back credit card. So I get back accepted, and it's a credit card type of MasterCard. So in my payment service, so when I'm going through my checkout flow, so instead of stopping me and saying like, oh, you have to input your credit card, has to be valid, this service will accept this kind of card. So that's really great. And again, you might have some kind of end-to-end test. You might have some kind of Selenium-based test or Appium-based test that does this, and that you have a credit card number for, and it kind of verifies, if it's a valid number, if it's an invalid number, if it's a valid card, if it's an invalid card. But again, that could be very, very heavy duty. You'd have to write some kind of Appium test. You'd have to find locators. You have to go through the entire flow. Do you really care about like the shipping address? That's maybe different from your actual payment information. So instead, let's go down a layer and test this service directly. So then once we've kind of tested this service, and it's much simpler to test at this level directly, you don't have to retest at that higher layer. So let's take a look at what might that look like. Let's explore. All right, so we're going to go back to here. And I have some credit card service tests. Okay, so now, so just to kind of get into this a little bit, so this is again written in Java. This is one way you could do it. This is really helpful if you have like a handful of tests to kind of, you might want to automate, or you want to put it into your like regression suite or something like this. So I'll kind of walk through what the tests look like individually, and then we can kind of like piece by piece kind of look at the different parts. So I have a few different test cases. Invalid card number. What happens if I try to pass in this 1, 2, 3, 4, 5, 6? It's not an appropriate credit card provider, and it's also doesn't have enough digits. So this should give back some kind of bad request or some kind of error code. And then in addition to this, we have a valid card number. So here's a card number that does satisfy the criteria. It starts with a 5. It's a MasterCard account or MasterCard card, which is accepted. And it's the correct length. So we should get back something good in that case. And then we might want to test like the actual messages, like what happens when you give a valid card. What kind of message do you get back? What happens if you test a card that's not an appropriate card type? So it's not a MasterCard, it's not a Visa. Do you get back like that message saying, invalid card type, or do you get back something incorrect? So let's walk through what that might look like. So now that we have this, and just so that I'm kind of being honest here, well, I'll validate that after. Okay, so let's walk through the pieces. So these are kind of written in a very AAA style test for API testing. So AAA, what is a AAA test? So arrange, act, assert. So you arrange your data or your sort of thing under test. So in this case, I'm getting a request, or I'm making a request and I'm getting back some kind of response based on my test case. I want to test this validate number endpoint with this data. So I kind of arrange that. Or sorry, I make an action that I want to validate or I want to look at. And then I arrange. So, I need some sort of actual output or actual result that I want to validate. And then I need some kind of expectation. So like, what am I expecting? Well, I'm expecting this code to be 400. This is what the actual code is. And then finally I assert. So like, I'm actually going to validate this. I'm going to have one or more assertions. Generally, if you want more than one assertion, like they should be kind of related or something like that. But a good practice is to have a single assert for every test. And this is where you get like your arrange, act, assert. So, and then last and certainly not least, because we're in the API world, we have a lot to work with in terms of data structure. So every time you make so this is a RESTful API, you make a request, you get a response. And because everything is HTTP, there's some standard stuff you can kind of expect. So one thing is that I will get back a status code. And what is a status code? So there is some standard status codes from 100 way up to 500 and something that basically can tell you, what they give you an idea of what happened to your request. So if you get a status code in the 100s, those are operational. Basically, that means like keep going. There's more data to come. 200 level mean everything is good. Your request was accepted. It was valid. Perform the action it was supposed to, that kind of thing. 300 level HTTP requests, or sorry, 300 level HTTP status codes suggest that there was small adjustment that had to be made, but everything was fine. So maybe there was a redirect, or like, oh, that URL isn't valid anymore. And so we had to sort of move it to this other one. So, slight rearrangement, but everything's good. 400 level status code means something was wrong on the client end, on the requester end. So either you made an invalid request, or the classic 404 error code. 404 meaning that like page wasn't found. So like you're trying to find a page that doesn't exist or wasn't found. Of course, there's like all infamous 404 page not found errors all over the internet. So 400 is like client side error. 500 is server side error. So that means something happened, like the request went through and then something bad, roughly something bad happened on the server side. So, 500 internal server error generally means like there was, something broke on the server. There was a bug in the code on the server, or like the request wasn't handled properly or something. So that's kind of roughly what we're doing, or roughly something you can follow as a guideline. So let's see how that looks for the invalid number case. So here I'm going to make a network request. Valid. I'm going to try to get this valid number, 1, 2, 3, 4, 5, 6. I get back the status code. So, once I get my response, I can get back the status code. And then I expect that to be a 400. So 400, so HTTP status code 400 means bad request. It means that like whatever data you passed in was bad or invalid, generally speaking. And I want to verify that these two things match up. And last and certainly not least, this network fetch function is doing a lot of the heavy lifting in this case. So let's take a quick look at it. So this was, this is just quick and dirty, kind of wrapping up some Java functionality. We're using this OK HTTP client. And again, Java kind of breaks things down. You have objects for like response and request, and request headers and response headers, and foobar and fooblom. So you kind of have to sort of massage all that together. So this is one approach. Oh, and then there's also error handling. So like what happens if your request is invalid, or what if it's ill-formed? Can Java catch that before the request is made or not? I don't know. So anyway, there's some code here. But the point is this method returns a response. So it returns an OK HTTP response based on this string URL. There's some error handling done. The URL gets translated, or the string gets translated into a URL. All sorts of Java magic happens. But you can take a look here. So anyway, so this isn't, so just to dispel any notion that this is some kind of magic that's happening. This is purely an HTTP client written in Java. So let's take a look here. So let's go back to our tests. And again, we can run these tests. So we can run these tests individually. So if we run this, so now I do want to point out something minor, but this test, so this was a single test executed. and it passed, which is good. You know, we did validate that through the UI, through the Swagger, or through the Open API documentation page. But this also works in this automated test. So the advantage here is now you can run this as part of a check-in for your code. You can run it CI. You can run on demand like we're doing here. You know, totally like automated. So let me see. Oh, and the other thing I wanted to raise is that executing the single test, it was a little bit slower than running a unit test, because in this case you have to make a network call, you have to fetch this URL, the request has to go across the internet, go into the service, it comes back. So there is a bit of there is a little bit more overhead compared to an API or compared to a unit test where everything's local, everything's compiled code, it's very fast. But it's still pretty quick, just took a couple minutes. Or sorry, just took like a few seconds. So we can take a look at the valid case. So again, we're going to follow the same kind of structure. We're going to follow, we have this service. We're going to use the validate number endpoint. And here we're going to pass in this data, which is supposedly a valid credit card number, given what the service does. So if I run this test again, and so again, I'm going to just get the response code, and I want to validate that response code equals 200. So 200 response means good. I think like officially it's like okay or good or something. Just means that it's good. No problem. You got a response back. Your request was valid. Everybody's happy. So you just want to validate this. So I can do this as well. Again, it takes a moment. It's not quite instant, but it only takes a couple seconds. It runs and it's valid. It all works. And last and certainly not least, we might be interested in validating the card type message. So for example, we're going to use this, or let's say I use this actually, just so you know I'm not making everything up. So I'm going to use the same credit card here under valid card number test, which just ran. We're going to use the same credit card number here with credit card type message. So this should get back a 200 response as we've just seen, but more importantly, it starts with a 5, so it should give back that this credit card is valid and a MasterCard credit card. So that's what this is here. So again, we're going to make this request. We're going to do some kind of action, and then we're going to arrange our test data. So we have an expected detail. So this detail should be that this card is a MasterCard card, and then we have to get the actual detail. And again, there's some error handling. It has to be done here. Because technically this could raise some kind of IO exceptions. We have to handle that. Thank you, Java. So we're gonna, but then this is the actual value. This is what the actual request body kind of produces. And in this case, I want to verify that MasterCard is somewhere in there. So let's run this. Okay. Great. So that runs and works as well. So we have kind of the basis of some very basic API tests for this service. And again, like you could build on top of this. Just leaning on if you're using Java. And again, like this is all within Android Studio. This is within Android project. So if you have some backend APIs, or not even backend, but like service APIs that you're using as part of your Android application or a web application, these would work exactly the same way. You can use some kind of network, like some kind of API or HTTP client to kind of make requests and get responses back. This is really great in these kind of simpler cases where you just want to make a few tests to make sure, like, okay, does the service work? Is it up? Do I get back the data I expect? It's kind of low overhead. It's kind of nice. Once you start to grow out your, excuse me, your API testing strategy and your test framework. Let's say you are in charge of testing an API service, or it's a relatively complicated API service. I'm guessing that an actual credit card service from a credit card data management or something would be a lot more complicated than the one I've put together. And so you might want to kind of find a more robust solution than just kind of rolling your own network request response. But it's definitely something that works in the small. And just because this is bugging me, so I'm going to open up this device, and I'm going to start up. What is this one? So in addition to Sauce devices, like I was just showing you, you may or may not have access to some real devices at Sauce, depending on your account. Sauce also does support emulators and simulators, so you can launch an application in a virtual environment as well. It doesn't have to be on a real device in a rack. It can also be a virtual environment. But also too, I'm just going to use this that's handy, something in Android Studio. So I've started up this application. Let's make this a lot bigger. Undock this. Perfect. Oh, no, not okay. Anyway, but then yeah, this is this issue. So okay, so let's just see what this looks like, making use of this backend service. So I've added my item to the cart. Check this out. Oh, actually, Josh. Actually, you know what? I think it is old. How this thing. Down. I'm going to build this APK. Sorry. Okay. I know. I decided a while back. I was like, I can do a mobile-based workshop. I can do a mobile-based workshop with APIs. It'll be fantastic. It'll be amazing. And then about a week ago, working on this, I thought, really should have just done a web thing. Oh well, you got to push your boundaries, right? You got to kind of work towards things. Okay, so now I have this API. Yeah, perfect. Okay, so now I'm going to power on this. Okay, to do restart the application. Okay, so let's see. Let's do this. This is way too complicated. Let's see if I can go to Sauce. So I'm going to take this. So I'm going to build this APK. Locate this. Go back to Sauce Labs. I'm going to go to my account. And I'm going to upload this APK. I'm going to just store it on Sauce. I'll use a Sauce device for this. Okay. Upload app. Okay, go here. There we go. It's uploading nice and peppy. That's good news. Okay, perfect. So that's now uploaded. We choose a device. And this time, let's try just using a virtual device. So I'm going to choose Google. I'm going to use the Pixel 4, and I'm going to use, I don't think I can use Android 11 yet, so, or Android 12 yet. So I'm going to start with Android 11. So now, so this is the same thing that, or almost the same thing, I guess I should say, that Android Studio produces. So this is an Android emulator. It's getting spun up on Sauce, totally virtualized environment. And this build of this application should make use of this credit card service. So if I actually go back, and I can show you where this is. So if I go to View, Fragments, and I go to, I think it's Checkout. This. Yes, here it is. So there's again. So this is just, you know, a very basic application for demo purposes. Wouldn't put this in production if I were you, but it is helpful for kind of learning and training purposes. So here there is a validate step. And I believe this validate step happens when you get to, well, I guess let's see. So this validate step validates the name, but more importantly, validates the card number. Aha, aha, aha. So once you put in your credit card service and your credit card number, so if you get some kind of status code, and this is actually like realistic, like application code as well. I've seen code in real life that looks like this. You basically make a request, you know, to some kind of service, and then you verify, like, you know, is this request, does it throw an error? So again, making use of the response code. You know, if it's higher than 300, that means that like something might have happened. This can also be higher than 400. Maybe that's better. Higher than 400, meaning like there was an issue on the client side or the server side, and this will raise these kind of credit card errors. So, you know, if I try to put in my credit card number, it gets this. If I try to put, sorry, not that. Right, if I put in my credit card name or the name on the credit card as well, that should be valid. This validate function will handle that. But also I can put in the card number. If the card number is inputted and is inputted correctly, like it's not like a bunch of letters or something, I still want to verify, like, is this credit card correct? Is it actually something that is correct? So let's do this. Okay. So here is my application again. I'm gonna try to buy one of these backpacks. Really love these backpacks. Proceed to checkout. Oh, no, but I need actually. And 20, 30, 40. Okay, Rebecca Water, and they're in Mandalay. See, that's someone from one of the other workshops. You know, it's not so great. Okay, so we're gonna do churro. And we're gonna do, okay, Cornwall. None of this is, all of this is just meant to be inputted. It doesn't actually affect the next page. And we're gonna do United Kingdom. To payment, okay. Moment of truth here. No, actually, I can leave that on. Okay, so card. So this is Rebecca Potter. And I'm going to put in a credit card of 123. Should be invalid. And so let's see. Oh, too many times. Oh, okay. So it does actually skip. It does actually do something. It should highlight. I'm not sure why that's not happening. I must have made something. Anyway, if you can reproduce, good job. But that should, so it should highlight and raise an error saying like an invalid credit card number. I don't know what's happening. The code is all there. But you can also build yourself. So, again, if you have Android Studio, you can build. Actually, I guess maybe we can build all this code up. Maybe there's something. I forgot a semicolon or something or other. But you can validate yourself that this behavior of this sort of fake credit card service does in fact kind of percolate through the UI. So yeah, so this is an example of where you can, instead of testing through the UI and kind of writing end-to-end tests to kind of walk through the UI and walk through a different flow, you could test at a layer below that and test at the API layer itself. Validate that your API works, that your services work, and then that's one less thing that you need to take care of when you are running end-to-end tests. Let's stop sharing. This as well. All right. I think we can take a 5-minute break. Oh, still looking for this. Take a 5-minute break just to let people stretch their legs and use the washroom as needed. Yeah. And it is. Okay, great. So we can start up again. Thank you for continuing to join me. So, there's one more thing that I want to walk through, and then I'm happy to do kind of an open QA or kind of walk over any of the other project that people have seen. So the last thing is how you can use API tests in UI tests. So we've kind of looked a little bit at how you can test something at the unit level, like kind of removing APIs and UIs and services altogether. We've also taken a look at how we can test at the API level. So once you have a service or an API kind of in your application, you can test at that level instead of invoking the entire application or the entire UI. So the last piece, and this is near and dear to my heart as someone who's a test developer, kind of at heart, is making use of those APIs that you have in your other tests. So in this case, I'm going to, because we're in the Android world, I'm going to show an end-to-end kind of happy path test using Android Espresso or Espresso. We have some Italians on the call, maybe. So Espresso, and that's a test tool specifically for testing Android applications. And so even in that setting, something not using Appy and using Selenium is kind of the classic case. You can make use of your APIs to make your UI tests more resilient and better. So let's take a look at that kind of example. And let's see what we can look at there. So back to sharing my screen. Open up Android Studio. So we're going to close this up. Okay, so here is a test. Here's an end-to-end test. I keep talking about end-to-end tests. So just to kind of recap what that is, an end-to-end test is where you invoke your application and you walk through some kind of flow. In this case, we're talking about, excuse me. In this case, we're talking about an e-commerce app. So you have a cart, you might add items to a cart. You might walk through and put in your shipping details because they'll be shipped somewhere. And then you put in your payment details because you have to pay for these items. And then once that's all finished, you kind of complete the checkout. So there are other analogous scenarios. If you have a sign-up process, you might have to provide certain information to sign up, such as email information and contact information while you're signing up, various other things as well. So here is an Android. Oh, sorry, not this one. Or, no, it is this one. Yes, sorry. Sorry, it's like something else. So this is an espresso test, happy flow. So it's marked as a test. So this is very, very similar to how you would write a JUnit test. But there's some additional utilities that Android Studio and sort of the Android project provide. This is very much a flavor of the philosophy of espresso here is the test is walking through different situations and performing different actions. And if something goes wrong with those actions, the test will raise an error and say like, something went wrong and provide information to stack trace, that kind of thing. So here we're going through the entire process. We're going to go onto the splash screen. We're going to select an item. We're going to confirm that this is the item that you want. We're going to try to buy that backpack. Everyone loves it. Do we want to add more to the cart? And then we enter like user information. So we're going to log in with this information. We're going to enter in this shipping information here for this address. We're going to perform all that. And then we're going to get to our checkout. So we're going to provide a credit card number and date, and so on and so forth. So we're going to walk through that. So let's see what this looks like. So the way that Android Studio works, oh dear. SauceCon, getting off to a rough start. So the way this works is that this will actually be triggered in, so by default, if I start one of these tests, this will start off in an Android emulator environment locally and execute on that environment. So execute against, a Pixel phone or a Samsung phone or whatever kind of target I choose. It will run against that and kind of validate these steps. So let's see what this looks like. Okay, so we're going back to this emulator, and then so automatically Android and Espresso are going to kind of take over this emulator and kind of set some state. So starting things up. Okay, and we kind of have to kind of reset some things here. Ooh. Okay, and I think I'm actually start things over here. So we're going to do yeah, I'm just gonna start everything all over here. I think this is a good practice just to keep things neat and tidy. So now so I've stopped all of my emulators that are running. I'm going to fire one up. This is Google Pixel 4 running Android 11. So I'm just going to fire this up. It's going to be all nice and clean and ready to go. And then so once this starts up, then we can run this test. My computers, there we go. My computer's working overtime. It's ridiculous how powerful computers have to be to just do the thing. Anyway, I don't know. Modern technology, am I right? Okay, so this is now starting up. This is a clean and pristine emulator. I believe it does have the latest. Oops, sorry, everyone. Okay, I'm just going to mute. We've found some technical problems there. I'm actually going to stop sharing for a moment. Turn it. Yes, sir, everyone. I guess, what can I say? Magic happens. Okay, so this is still taking some time. Anyway, so that's booting up. So let's see what happens. We can run this test. It's Espresso test. We're going to run dashboard checkout. So this should start up the application. Okay, so we're just waiting on the application to start, the pixel to start, and then the application to start. Nope. Oh, look at this, and it's crashing. Look at that. And then testing. See, it's like, and this is, I mean, it's funny because I have been a test automator for like 12 years, and I started with Selenium, or no, actually that's not true. I started with Silk Test, automating desktop Windows applications, and it's interesting that, I mean, and Silk Test is not like a new technology. It's not new. It's not flashy at all. But you still see the same problems with UI automation, whether you're talking about a desktop application for something like Windows, a mobile application for like Android or for iOS, or a web application on a browser. You still just get like all these like configuration issues, and the environment is, letting you down and all this kind of stuff. So let's do this. Just verify that I can actually get some kind of get something there. Okay. So here we go. So the application starts to run. It's going to run this environment, starting up. Everything gets attached. Everything starts running. Okay, my demo app starts up. And we're going to walk through the flow. So this is like adding the backpack, adding it to cart. And we decide to check out, entering your information, again, like using like native keyboard actions. So this is really what you can expect like an emulated environment to look like. So we're going to enter in checkout information. Some additional things as well. Okay, we're going to go to payment, and we're going to fill out some of the payment page as well. Okay, so this is kind of an end-to-end scenario. And again, entering credit card numbers, names, addresses, that kind of thing. And then the test kind of runs. So because the test got through, and if we take a look just one more time, because it's definitely a stylistic choice. If you take a look one more time, and you know what, I can kind of. So we take a look here, like there aren't really any sort of assertions. It's just kind of, performing actions, performing scrolls and clicks, entering text. And if something goes wrong, the test would fail. So if you're unable to enter text, if you're unable to find a particular input box or something, then the test would fail. So this test is pretty good. It's not too bad. Does kind of walk through an end-to-end scenario. It runs relatively performantly. But the thing I want to point out is that we've kind of hard-coded some of our data. So why is this bad? So hard-coding your data, so one, it's not reusable. So if I start using Rebecca Winter here, I have to use Rebecca Winter this string other places as well. So I have to kind of violating do not repeat yourself in sort of an obvious way. So I could abstract that out and could have put it in a class somewhere. I could do that, but it's still hard-coded. I'd have to change it. Something might happen. What's more interesting is something like with credit card numbers. Credit cards expire. Credit card numbers change and update. So hard-coding this, like eventually this credit card will be expired. So if I do this workshop in 2025, in theory, this credit card would be invalid and the test might fail out. Again, it could fail out like any time. If I'm running this in February 2025, my test mysteriously fails. So like any sort of test, you're relying on specific date times can be very flaky. If you kind of hard code dates in there, it's very tempting to do that. I've done it. These sorts of things. So how can we get around this repetition or these potentially flaky scenarios? Well, one idea is to go back to our API, because if you recall, let's go take a look here. So if you recall, our API does have like a validate card number endpoint, which is very helpful. But it also has this get test card details endpoint. So this is an endpoint. Again, you can kind of think of this as either something in your control, something that like you can manipulate and you can ask developers to do, or you yourself can do. You can say, you know what, I need test data. I want to get it from the service itself. I want to do some validation even before it gets to my application. Or perhaps this is offered by the third party. So maybe the third party, some kind of credit card provider, and they say, well, we can give you some test data that will always work or kind of work in this time frame or work under these circumstances. And so that's what this is. So let's try it out. So this is a very easy endpoint. It's a get. It doesn't take any parameters. So I can just make the request and I get back this kind of thing. So I get back a 200 code and I get a credit card object, if you will. So it has an expiry date. It has a valid credit card number. It has a card type. And the cool thing is, if I execute this again, I get different data. So it's not just a single static card. This does have some interesting behavior in that you get different valid cards every time. So that could also be really helpful. It could provide some realism in your tests. It also kind of prevents against flaky tests where the credit card that you've been using for the past year suddenly expires or is suddenly invalid, and now your tests fail, and your tests are failing in the middle of the night. No one knows what's going on. So you're kind of thinking ahead and trying to prevent against those kind of scenarios. So let's see how we can use this. This is where I do my best Martha Stewart impression, and I say, like, I have something that I've prepared earlier, so let's get that out from the oven. So I'm going to go and check out, actually get tag, and I want espresso. So this is the old way of doing espresso, where I have this valid end-to-end scenario and I'm just hard coding a bunch of data. But now I want to include services. So I've done this. Okay, let's get to that. So here, instead of hard coding my data, I am now using this service. I'm using this credit card service. Again, I'm just fetching the body of this request, or sorry, of this, well, I guess of this endpoint. So I have this get test card details endpoint. I'm going to make requests. I'm going to get that data back. The data comes back in JSON, of course. And so I parse it and I get out the data that I need to. So in addition to using the name, now I can get the number from this service, and I can also get the expiry date of this service. So this is a little bit more resilient. This is one way that you can use your API in your end-to-end tests, is to retrieve test data. I happen to know, speaking of credit cards, a very large credit card company that you've heard of that works with Sauce. They built out an entire integration environment partially to solve problems like this. So if you're a tester and you want to test, I have like a credit card account and I want to do this kind of scenario. Credit card data can get, or any sort of financial data can get very complicated. You have different rules in different locales, and you have to have like valid accounts, and the accounts have to have certain rules, and maybe you want to do a deposit into like a checking account, but you can't withdraw from like a savings account, like, so you have to do all this kind of logic. And so this company started building out like an integration environment specifically to address these kinds of issues. So really, really interesting. Again, very large scale solution for large scale problems. In this workshop, we just happen to have this service that just happens to help us out. But it's something that you can look into, again, if you have access to your API layer as a tester, as a test automator. Or B, this is something you can ask your application developers, your backend developers to provide for you. If you know you need some test data in a certain form, you can ask, hey, can you create an endpoint and secure it somehow or whatever. Again, like this is pretty insecure, but we're all friends here. But you can talk to them about, can I just retrieve this data directly from an API call or from a service call, kind of make my life a little easier. So if I run this test again, let's see what I get. Fire up my trusty emulator here. All right, it's thinking about it. Uh-oh, unexpected what? Unexpected packet. Uh-oh. Who's making Amazon deliveries? Okay, so the application starts up. And again, I'm gonna buy this backpack. Love this backpack. I have one of these actually, great backpack. So we're gonna check out, log in with our credentials. And as you can see, when you invoke an application's UI or you invoke the entire application, things slow down considerably. So I guess we're here. Right. So here so now I've made use of this credit card. I've made use of this expiry date. Maybe I need security code. And so now this service is now independent of my test. So if my credit card needs to update, if a certain number is no longer valid, or let's say, eventually the payment provider does support American Express or Discover or some other credit card, you can build that into your service as well. So you no longer have to just rely on MasterCard and Visa. You can kind of insert that stuff in there. So that's like a pretty cool usage of APIs in end-to-end tests. And just as I was saying, as you can tell, either from the tone of my voice, but also just watching the executions, end-to-end tests take much longer than API tests, which take longer than an API test, in turn take longer than unit tests. So there's also a speed trade-off, right? It's important to test, at the UI layer. It's important to test end-to-end test scenarios. Like, does this thing work? Does the application work? Can I check out? Can I actually add items to my cart as an end user? And it's important to do that, in automation or not in automation, using exploratory techniques. But the trade-off is these tests are more complicated. There's more infrastructure. Like here, like this test is just a lot more code than the unit case or the API case that we kind of showed. And there's more considerations, like, you need to have test data, and where does that test data come from? So again, very important, and using tools in your toolbox can definitely help out. But definitely, like, end-to-end scenarios are, as you may know, it's just more resource intensive. So kind of, choosing the right or choosing the appropriate layer to test at can definitely help out a lot with your testing strategy. All right, so we're finished the content that I have that I wanted to present. Definitely have half an hour for questions or comments, either from the Sauce API folks or from participants. Thank you so much for joining. It was really great. So let me. Uh-oh, I wasn't sharing my screen, was I? Oh, no, I like missed all of that. Oh, no. Oops. Okay, turns out it was good news. Okay, but yeah, any questions? Again, I'll include the link. Yeah, that's pinned there as well. the service, which you're free to play around with. Let's see what happened to that old API. That is so. Yeah, I'm kind of reading old things. That is. Okay. Oh, so we do have some questions. Great. So question. So in scenarios, so I'll kind of repeat the question. I guess like everyone can see it. But in scenarios where the application under test is not built around APIs, how would you compensate the API testing pattern in alignment with the test automation pyramid? Oh, okay. So this is a really great question. So if you recall, test automation pyramid, kind of, at the top you have end-to-end tests that are kind of small and the smallest portion of the pyramid. In the middle, you have API and service integration layer, which is kind of the middle layer of the pyramid, and the bottom is the unit layer. And so the unit layer is the largest proportion. So I guess the question, so the question is, what happens if you don't really have like an integration layer, or like what happens if the integration layer is very thin? This can totally happen, especially in modern web development, where you have something like React, right? And React can handle a lot of stuff for you. React components, you can do like a lot of software development like at the UI layer effectively, or the front end layer. Yeah, right, yeah. And then your backend is something else, like Java or Python or something else. So yeah, this is a really good question. So like I guess like one answer is like, I mean, work with your context. If you have an extensive, like I definitely recommend, if you have an extensive API layer available to you, whether that's public or private facing, there could be internal APIs that aren't, that you as the developer can use, but aren't available to like end users or aren't exposed to kind of the wider world. Make use of that. If you don't have that, and that's intentionally by design, then I would still, especially in the JavaScript world, or the JavaScript front end world, I guess I should say, definitely make sure that you are trying to test at the level of abstraction that makes the most sense. So, and I'm not a JavaScript person, unfortunately. But like, for example, in React, if you have a bunch of, I don't even know if people still do this, if you have a bunch of React components that have logic within them or kind of depend on logic in pure JavaScript or something, see if you can test at that. You can test at that layer, testing in pure JavaScript or testing those components using some kind of React tooling or something, instead of saying, okay, well, I'm just going to invoke the entire application, walk through it, go to page 4 of the flow, so I can test this one component. You want to reduce that overhead. Oh yeah, so hopefully that answers a little bit of the question. Oh, can we run API tests in parallel? So yes, great question, and the answer is yes. So my lovely colleagues are going to discuss API testing with Sauce API, or Sauce Labs API, I guess I should say. You can definitely, so a lot of test tools do allow for, especially if you have like some sort of GUI, or you have some sort of like interface, they do allow for running tests in parallel or kind of some kind of concurrency. In the tests I showed, you can run those in parallel. I didn't set them up that way. In fact, let me share my screen here. I can turn that off too. So this is really an interesting question, because when you talk about end-to-end tests, or you talk about Selenium or Appium tests, like parallelism, like, can I parallelize is a big question, and it's complicated, and you have to figure out tooling and all this kind of stuff. The good news with unit testing and with API testing is that it's often a lot more straightforward to at least parallelize your tests. A couple things to keep in mind. And I don't recall it here, but you can, for example, in JUnit does provide some kind of parallelization approach. I don't know, it's like parallelization or something. I don't know. But there are some annotations, something I guess parameterized, or there are some tools in JUnit that you can structure your tests to run in parallel. The good news is, there's a good and bad news for testing at the API layer. The good news is you can just do this in code and try it. You can just design your test to be run in parallel, and off you go. You don't really have to worry about unlike with Appian tests, like, do I have enough devices? How do I handle different sessions? Can my computer handle that? Do I need to, like, get Sauce Labs in order to, help with that, which of course we can do. And you can have smart people like me kind of help you with these exact questions of how to parallelize on Sauce Labs. Big value add there. So the good news is it's easier to just try this out with running tests or API tests in parallel. The bad news is, or potentially the bad news, is that because API tests depend on some kind of service, and you start running things in parallel, you're actually potentially putting a load on your service, right? And you might, sort of as a side effect, do some kind of load testing or stress testing. Your service might do fine when you run 10 tests in series. It might start to struggle a bit when you start to do 10 tests in parallel. And that could be a question of resources. If you're running against some kind of test server like I'm doing here, maybe it's just not powerful enough. It's just not configured well enough. Maybe you're just putting a lot of data on the service. Maybe the service wasn't designed with concurrency in mind. Probably not, but maybe. So there's trade-offs, but the answer is yes, you can absolutely run this in parallel. Good exercise, if you want to try that out. And jest or equivalent. So yeah, jest is a really interesting one. So I just had a conversation a few days ago with my coworker Win Sellis, a really smart guy. He's kind of the JavaScript expert on the team. So it sounds like jest is not supported as well. It kind of came out of Facebook and that group. So it sounds like the Facebook backing for jest is falling away. So jest may not be supported as well. The other thing that's interesting about jest is that it is, like JUnit, purely a testing framework. So it's for kind of arranging test code and executing test code. You can do that. You can use jest with something like an API service or with Selenium WebDriver. You can do that. So the downside is it could be more work. You have to do everything yourself. So now you have to figure out, like, okay, here's my test framework and here's my before and after hooks and all these sorts of things with jest. Now I have to introduce my API, and now I have to do. So like you could get some benefits in that, like, you can customize things, but you could also have some downsides in that you have to customize things. It's that kind of trade-off. It would be similar for things like if JUnit has this situation in TestNG and Java. I'm not familiar. I'm not up to speed enough on the JavaScript world to kind of know what, like, jest pops out, but I'm not sure what else is there. So yeah. And let's see. Okay, can I mix both API and unit tests as part of an end-to-end integration test? Yes, you can. So so you definitely can. There's a couple ways you can think of this. So one way is you have you just have a bunch. I mean, I'm in the Java world here, I guess. So I have a bunch of tests. The JUnit tests, they execute. They're in a tests directory or package somewhere. And some of them have API and some of them have UI and some of them have both, and they just run and they execute. You can totally do that. You can 100% do that. It all kind of falls into the JUnit world. Another thing, so like that's sort of like the approach of I'm just going to put a bunch of tests in my, my project, mix them together, and it'll all work. You can do that with Java at least. Other languages would be similar, or other, I guess I should say other ecosystems should be similar. You could also, another thing you could do, depending on your needs, is if you have CI, you could also just break things up into like, I'm going to run my unit tests first, then I'm going to run my API tests, and I'm going to run my service tests, then I'm going to run my end tests. Or you could run them all concurrently and kind of break them out, kind of make use of your CI system as well. But yeah, there's nothing stopping you from mixing API and UI tests. It just depends on how you structure them. All right, in API testing, does it make sense to manage the test data in a separate file? Like in this example, yes. Okay, so great question. Love this question. So my other colleague, Thijs Fortner, this is kind of his approach, but other people have come up with it. You can kind of think of, how does this go? So like the first step of, test data is just, hard code it in place. And this has all the problems that I kind of mentioned. The code duplication, you have to find where it is, you have to update it manually. If test data gets out of date or something, you have a lot of work to do. So exactly like you say, next step is like, well, I'm going to put this into another file, and then I'm going to draw from the file. Then it's only in one place. I only have to change things ideally in one place, right? Like, so I've seen this with CSV files. You kind of have a CSV file, kind of spreadsheet with data, and then you kind of pull the row that you want, or you pull the column that you want, and then it's just kind of updated. This is also good, or this is a step better than kind of just hard coding stuff all over the place, because at least you have everything in one place. The downside is like you still kind of have hard coded data. So again, your data could get a date, or someone adds a row, and then you're choosing the wrong row, and your tests get all weird. So the best or the most effective thing is to apply a just-in-time a just-in-time approach. So that means if you need a test data, so if you need a credit card, you pull that credit card data from somewhere, from a service or from maybe from a file or something, but you get it just in time. If you're able to do this, you can pull this from like some kind of sanitized database. So it's like, okay, I need this. I'm going to pull it via an API call or via some kind of service database dump or something. I'm just going to get it exactly where I need it. And so it's kind of managed somewhere else, and then it's all good and validated, and you get it. So those are kind of like, hard code in place, hard code in one single file or in some place, which is an improvement, or kind of, get it just in time. There are kind of three ways to think about it. Hopefully that's helpful. And it totally depends. Like, I mean, some people are like, there's no way we could ever do just in time. Like, I work at a bank, and there's like, we have to pull data from like 18 places, and one of them's a mainframe, and the team only updates the mainframe every like 2 weeks, and hey, like, no problem. Like, got to do what you got to do. So, if a CSV file works for you, great, do that. Does it make sense to run the different tests or different tests for each API, or chain the APIs in the test, meaning depending on the scenario? Oh, okay. So this is a great question. So what I did is, so in the examples, she's not happy. So in the examples that I showed, I was testing one endpoint once. So like, does this, and you can get pretty far, like in terms of API testing, you can get pretty far that way, in my experience. I make this good request, do I get back a 200 level response? I make this bad request, do I get a 400 level response? That sort of thing. Do I get a 404 versus a 403? Like, you can kind of test those kind of scenarios too. Something else you can do, and I didn't kind of illustrate here. So when you look at that espresso test, it kind of invokes the app, and it's slow, and you're waiting for the emulator. And So what you could try, depending again on how your application is structured, is to chain together API calls to kind of follow that workflow. So for example, if I have a shipping API service to get like data for shipping to validate like postal codes or zip codes or whatever, I could use that service to kind of, to handle the shipping element, and then I could use my credit card service to handle the payment element. And I could kind of construct a workflow. Like, does my application work? Like, does the business logic work in a flow? That's another really good use case for APIs, because again, like, you get a performance gain. You don't have to invoke the whole app. If someone changes a radio list to like a drop down, your tests don't break. It's another kind of thing with UI automation. So yes, totally. Another really good use case for API testing is to test business flows. But yeah, no, good point. Let me see. So we're running a little bit ahead of schedule. I know it's too bad my videos didn't have sound, because they were fun and quirky like me. So yeah, maybe I'll post them on YouTube or something. They're not that great. So yeah, I don't know if Julian or Sangeet, if you have anything to add or any comments. No. Maybe not. Yeah. Is there? I'm trying to think of like any other API stuff. Yeah, but like this, like I said, this repo is open source. Definitely take a look, play around. As you may have noticed, or as you may have been told, this workshop will be recorded, or is being recorded, and will be made available in the next few weeks. So definitely, like, you can take a look. Oh, and there are some more questions. Oh, there's a Q&A tab. Oh, okay, let's do that. So currently, the application I am working with is the application which I'm working with, like a UI, connects to an API, and the API connects to a database. Okay, totally a thing. In this case, can we use the API as a source to see if the data is displayed correctly rather than comparing data from the database? Yes, you could do this. So you could do, yeah, like this is a very common kind of structure. Sometimes APIs are really just a thin layer over a database. You just have to access, like you just need some kind of way to access the database, maybe some light logic. And so you could totally do this instead of going to the database or using the UI itself. You could use the API to pull out data. You could also say like, okay, I know what this looks like in the UI, and maybe the UI has some additional logic. And so I can get what the data is in the API, and I can compare the two. Totally also a thing you can do. That's smart too, because then you can rule out, like, is this a bug in how in my UI layer, like maybe the data isn't rendered properly, or like there's some kind of resolution bug or something design issue, versus like a data issue, like something's actually like incorrect in the database or in the API. So yeah, definitely a good idea.
And to add to that, I would say, yeah, I would absolutely use the API to validate the data rather than pulling directly from the database for multiple reasons, really. One of the biggest ones being, especially if you're running these tests from a remote location, generally your databases are not going to be accessible from the outside, and nor should they really be. But APIs, on the other hand, can easily be made accessible to the outside. And so testing from an external source is much easier to do from the API side as well. And then API connections tend to be a little bit more stable and easier to work with than querying a database for a large table and then parsing that down and pulling data that way.
Yeah, definitely some good points. Yeah, databases, it's true. Databases tend to be more locked up, obviously. So yeah, the APIs are also kind of a gateway to that, I guess. Yeah. So yeah, good point. And there are some more questions. I can't believe there's more questions. Okay, which approach is good to parse nested JSON? JSON Path or Pojo? My answer is use Python, use Beautiful Soup. like it's I'm not a big Java fan. I'm going to be honest with you. And this is part of the reason why is that like when you get data from JSON, it's just a JSON blob, right? It's just like a big old set of JSON. It can be nested, that kind of thing. There are good JSON parsers like JSON from Google for Java. Beautiful Soup from Python, if you're in the Python world, is a very good tool as well. So it kind of just depends on like what you're trying to do. Like the nice thing about JSON, like if you're doing something kind of heavier duty and and it makes sense for you to, or you already have a POJO kind of constructed, like, okay, this is going to be a data holder, it's going to be a container, so I have all my getters and setters, I have all my fields. JSON's kind of nice because like it just uses that, like it just can just make use of it and pull it out. Whereas like with JSON formatter, like if you're just sort of inserting a string and you want back your JSON into something consumable, I guess if you're doing something easier, yeah. I haven't worked with in the Java world that much with consuming JSON, so yeah. Oh, we have a question. Yeah. Have you run into concerns where integrating API tests may not be representative of the user experience for end-to-end tests? An example I can think of is, obviously worst case, is a certain UI element disappears, but your test is making an API call, so your test misses the users. Oh yeah, so this is a good one. Okay. I have not had this kind of thing happen to me, but I can see where you're coming from. Where, and I mean, and this is kind of I mean, in the mobile world, this is especially really important because you know, mobile, like how users actually are interacting with their device makes for a big, like user experience is huge, right? And so yeah, it's totally like a thing where, you know, your end-to-end, sorry, your business logic all passes. Like let's say you have API testing individual services, they're all good. You have services working together in integration tests at the API layer, that's good. And then you run UI tests, they all pass, so kind of functions, that's good. But then you hit these situations where it's like, well, you know, for some reason, user logs in, you know, button disappears too quickly, and it's kind of a bad experience. It's hard for them to log out or something. And like this is, so there is a really good representation of the test automation pyramid, where above end-to-end tests, you have this little cloud. And the cloud is like exploratory testing, or sort of like, you know, manual testing, I guess is one way you could say it. And it's like, you know, everything might work and it might function well, and you might have tests to cover all these important scenarios. But like you need like that little bit of like, or maybe a little bit is kind of the wrong way to say it. You should think about, you know, just testing, you know, from a user perspective, like getting a human being to look at things to make sure, like, you know, does this make sense? Does it work? You know, so I mean, in a way, like this is kind of where that comes in, and it's really easy, especially when you're a very smart test developer. Like it's easy to think like we've got good coverage and we've got all these testing, we've got all these layers, and but like, you know, it's important to remember like it was the human element, right? And I'm doing this for mobile, but it's the same for web as well. So yeah, really good question is like what happens when you're kind of missing some coverage, you know, just based on how human beings work. So yeah, no, it's really good question. Yeah, and some people have some errors. Dependencies used in Gradle build. This worked. I was using JDK 11. Definitely use JDK 11 or higher. JDK 8 won't work for reasons I don't know. Use Android Studio, probably more than IntelliJ, because Android Studio has some additional things in it. Is there something else I had an issue with? I'm not even going to bother to talk about like emulator and device setup because it's just too complicated. Just, you know, pick your favorite and it'll work. I've tested this on Android 11 and Android 10. I don't think I've tried it on Android 12. Mileage may vary. So yeah, and I think that's it. So I think Julian and Sangeet will take over in a few minutes. So yeah, I'm the theory person. This is how to think about APIs. My colleagues coming up will kind of show you, how you can use a tool like Sauce API or Sauce Labs API to kind of realize a lot of these wonderful things. I'll leave it to them, and thank you all for joining.
Okay, thank you very much, Josh. Good workshop, good presentation. Thank you very much. Okay, so can anyone hear me fine? I'm going to share my screen now. And hopefully you guys are seeing my screen. And I will start my presentation now. Okay, hello everyone. The workshop that we are going to work on today is called Integrating Contract Tests in a Continuous Integration Pipeline. My name is Julian Vargas. I am engineering manager in the API testing team. But first of all, I would like to do some overview just to be sure that everyone is on the same page about what is contract testing. So normally when you have an application like the one that Josh was presenting, you have the consumer side of the API, and you have also the producer side, which is usually the API server. And you have connected, you can connect them so that the consumer can obviously consume information from the API and post information to the API. When it comes to testing, we can, the idea of contract testing is to test them separately using the OpenAPI contract definition. So the plan is to have like a document where you have all the grammar, all the requirements for the communication to happen as expected, and both parties should respect that contract. In the case of the consumer, of the API consumer, we need to use a mock server, which in our case for this workshop we will use Sauce API testing bias tree, which is a Docker image that you are going to pull in a bit, so that we can mock or create mock endpoints as described in the contract. And also we are going to use API testing in the cloud to be sure that the API producer is also following the grammar described in the contract. Okay. Some overview on the continuous integration process that we are going to follow or implement in this workshop. We are going to have mainly two components. One in the cloud, which is API testing, our product, and our local host, which we are going to configure as a continuous integration server. In our local host, we are going to develop, which is most of what we are going to do today. We are also going to commit the changes locally. We are going to push locally. And locally, we are going to also run all the tests, all the verifications to be sure that the tests are passing and that we are also following a TDD process, a TDD flow for implementing our example API. And later, we are going to release the application. In our case, this is a very small application. Release is basically just run the application in a local port. What we will need for this workshop an active Sauce Lab account. So please be sure that you can access to app.saucelab.com. I'm going to use my username and password. And I'm going to go to use the Europe zone. Please, everyone, try to follow along and log in into Sauce Labs, because we are going to create our project and retrieve some information from this account. Is everybody following along? Well, I hope so. So, back to my presentation. The other thing that we are going to need is Sauce Connect. You can Google it, Sauce Labs, Sauce Connect, download it, and please be sure that you can run it and that you are able to follow this example. When you go to tunnel and proxies, please be sure that if you copy and paste this into your terminal, it runs properly. This tunnel will allow us run things from the cloud, from Sauce Lab API testing in the cloud, to access our local host where our application will be running. Also, the code that we are going to write is in TypeScript. And this is basically because TypeScript nowadays is widely used. So we are going to use TypeScript, and we choose Dino because Dino by default runs TypeScript, so we don't need to install Java and Babel and the transpilers and all the stuff. So it's much simpler to set it up with Dino. And also we are going to use Git for source control and for setting up the CI server. This is the requirement or the description of the application we are going to implement. User story. As a user, I want to be able to know which is the best sauce to use for a given food so that I can enjoy my food in the best way possible. Acceptance criteria. This will be a command line application that will receive a food name and will print in the terminal the name of the best sauce for that given food. For example, if I do sauce for and then pass fries and as parameter, it will just print out ketchup. This application will consume an HTTP API with one endpoint /sauce with a mandatory query parameter for that will contain the name of the food. The API will return a JSON document with only one property, sauce name, containing the name of the best sauce for the given food. For example, the JSON would be like this, sauce name and then ketchup. The server will expose the endpoint in port 8000 /sauce, and for any GET request received, it will use the query string parameter for to read the food and respond with the best sauce. Please, everybody, hold on. I'm going to give you the address in the chat session chat. Please be sure that you can clone this repository. This contains the template of the code that we are going to work with today. And I'm going to do exactly that. So I go to my terminal. And then I cd into sauce recipe. Okay, back to the presentation. The folder structure is as follows. The root folder, sauce recipe, which is the repository that we just cloned. And inside we will have a folder for the client and one folder for the server. The client would be obviously the API consumer, and the server is the API producer. Inside the client, we are going to, as I said, follow a TDD process for implementing this application. So we will have our tests, our implementation, and just for convenience, since we are starting this implementation from the front-end perspective, I decided to put the contract in the client folder, but the location is not important. In the case of the server, we also will have the tests, the implementation, the HTTP server that will expose the business logic to the port 8000. We will have a YAML file with the information for opening the tunnel. And we will have a test suite file where we are going to list all the tests for our entire stack. So we are going to start with the consumer side. So for this implementation, we will implement the API consumer following TDD, as I just mentioned. We're going to include the details in the contract. We are going to describe the contract, what the consumer is expecting. In order to properly test the consumer side, to be sure that it is properly making HTTP requests, we are going to use PyS3 as a mock server. So let's jump right in. Sangeet, is there any questions?
Nope, everything looks good so far.
Wonderful. So the first thing that I'm going to do is, I hope everyone is familiar. I'm going to use Tmux to split my terminal. But if, first of all, I'm going to really quickly describe how Tmux work, just in case somebody doesn't know. Tmux will have this number here indicating that I'm working in the window number 0. I can open all windows. In this case, I have two windows, number 0, number 1, and the star indicates that I'm in window number 1. If I switch to window 0, the star will be pointing to the window number 0. Okay, so what I'm going to do here is I have my files, and inside every Git repository, I have something called the hooks. So I'm going to rename Git hooks push .sample, and I'm going to rename it to just remove the .sample extension. And then I'm going to open that file. And then I'm going to delete everything inside that file. Okay? And here, I'm going to do the following. Shebang bin bash login. This file will be responsible for triggering the entire CI every time we push changes to the remote repository. Okay, please, everyone, rename the file. Notice that I'm in .git/hooks/pre-push, and this is the content that I'm going to use for now in this file. I'm gonna wait for like 1 minute just to be sure that everyone is following. And please feel free to ask any questions or anything. Okay. I'm going to close this file. And the next thing that I'm going to do is open the test suite. And in the test suite.sh file, I'm going to just echo tests are passing. So what I'm doing here, this test suite.sh will be the recipe that usually you set up in Jenkins or in CircleCI or any other CI server, is where you describe how the order in which your tests are going to run, etc. And I'm going to close this file. And the next thing that I'm going to do is create a remote repository to push my changes. But since we just cloned this repository from GitHub, we need to remove the current origin. So I will do git remote rm origin, so that we are no longer pointing to GitHub. And I'm going to create a local remote repository to push my changes. So I will do git init /tmp / sauce recipe remote. There. What this is doing is that in this folder, in my local computer, is going to create a synchronization point with this modifier. And what this does is just create a Git repository without the content files, just the history. And the next thing will be git remote add origin tmp sauce recipe remote. So every time we do git push origin master, it will push to that folder in our local computer. So now I'm gonna pause for 30 seconds to be sure that everyone is following. Okay, the next thing is I'm going to add my test suite, which is containing only the echo tests are passing, and I will create my initial commit. Next step will be git push origin master. And look, since we have the hook configured, the pre-push, this is going to print this message on the terminal, running tests, and then the message from the test suite, tests are passing. So right now we are good because all our tests are passing, which is kind of trivial because there are no actual tests running. Just for fun, I'm going to do one extra thing. I'm going to create an empty commit, and I will push again to be sure that it is working. I create this empty commit, and then git push origin master. And it's working. Okay, every time we push to master, it will trigger the CI process to verify our tests. Okay, now we are going to start with the consumer side. So I will use the window number 0 to run code and the window number 1 to edit code. So here in window number 1, I'm going to cd into the source client. And this folder, I have 3 files. For now, I'm going to focus on the tests. Test.typescript. So here we have the skeleton of a unit test. The test that we have here is it returns the source for the given food. It's going to be an async function because the client is going to perform an HTTP request to a web server. Therefore, it will work with promises. The function that we're going to call is called source4. That will be our client logic. It will receive a string and it will expect a string as return. So here, if we follow the example given in the requirement, if I do fries, I expect what? Anybody in the chat, please? If I give fries, what is the best sauce for fries? Wonderful, ketchup. Ketchup. Right? And now we are going to run the tests because this is a TDD process. So I'll do home / dino test allow net. Running and good. Sorry. Source client. I run the test again. Good. It says that source4 is not defined. So what I'm going to do here is to import source4 from .ts. Okay. "30 seconds for give some time for everyone to follow along. Okay, I'm going back to the window number 0 and I will test again. The module source code could not be parsed, whatever. Okay, this is good. Now we are going to open source.typescript, which is the client logic. And here we have the function. So we export an async function called source4 is not receiving anything yet. And this is the skeleton of the client logic. So notice that what I included here is just like a basic template. So the first thing that we are going to do is source4 should receive a parameter. So the parameter, let's call it food, and it should be of type string, right? Since this is going to perform an HTTP request, the return type is promise of string, which is the type of the source name. And we are going to fetch that information from localhost / source for then what? We need to interpolate the parameter. Does anyone have questions so far? Is this clear what I'm doing here? Let me see the chat. Sorry. Do you guys want me to repeat anything or is everything clear so far? Okay, so once again, the client logic will receive the food. It will make an HTTP call to the endpoint source, query parameter for interpolating the food, and then I'm expecting a JSON. And from this JSON, according to the requirement, what I'm going to retrieve finally is the source name. Okay. This is my client logic. Now I'm going to run the test again. Okay, wonderful. We made some progress. This is still failing because obviously, okay, Kitty is asking for the push hook file. Okay, so in the root folder, I do git hooks the push. Remember that the original file was sample. So I have to remove this extension to make it work. Just by removing the extension, Git will automatically run the script that is inside that file. And this is what it contains. Shebang /bin/bash. I'm using a login shell and then echoing the messages. And the last line is source test suite.sh. Okay. As I was saying, the test now is failing because it is actually trying to make the request to localhost 5000, but nothing is running in this port. So in this point, we are going to finally use Pystry as the mock server. But Pystry doesn't run, by itself. We need to give some details. So for that, I'm going to exercise to enter the details in the source contract.yaml. Okay, this is a basic template for the contract. So it's an OpenAPI 3.0 contract. The info is version 1.0, and we are going to include our details here. So the path, it will be source, which is what the requirement is giving us. So please, everybody, enter /source. Line number 6, the verb, the HTTP verb will be get, which is what the requirement is giving us so far. For the parameters in the query string, we will have a parameter named for, right? In the schema, the type will be string. It will be required because, again, this is what the requirement is, the user story gave us. And as an example, I will do fries. Right. In the responses for now, for today, we are going to only work in following the happy path, which is 200. So the content is as follows. The properties, so we have the application, the content will be application JSON, the schema, type object, properties, and in properties we will do source name, right? That will be the property. It will be required, and the type will be string. And finally, we are going to provide an example. I'm going to pause for another very short 30 seconds. Again, the things that I modified were line number 5 /source, line number 6, the HTTP verb, which is get, and then the name of the parameter in line number 9, 4. Then in line 11, the type, which is string, is required through the example fries. And then I jump down to the properties in line 22, source name, required true, type string, and then I provided one example, source name, ketchup. Okay. I have my, my contract defined. I'm going to open a third window, window number 2, as shown in at the bottom of my screen. And here, what I'm going to do is run pastry. So first of all, I'm going to cd into sauce client folder, and from here I'll do docker run dash volume, and I'm going to map my current folder, which is the sauce client, to /specs inside the container, and I'm going to map my port 5000 to the port 5000 inside the container. y.io / sauce labs -u. Okay. I know this is long, and no worries, I'm going to share this in the chat soon. So I have pastry specs source contract.yaml validate request. Okay. First of all, I'm going to hit enter. And it's working, yes. And hold on, I'm going to share this in the chat so that you guys just need to copy paste. Go ahead. If by any chances you don't have the pastry image in your computer, which is most likely, that is going to take some time. So in the meantime, I'm going to very slowly explain how this works. I run the container. I map my source client folder, which is the location where I have my contract. This is the source client path to /specs inside the container. I map my port 5000 to the port 5000 inside the container. I run the container from this image, which is pastry. And I'm going to use /specs source contract.yaml to tell pastry the endpoints, the verbs that are going to be, basically the description of inside the contract for to allow pastry to emulate the server. So since the contract has one get for /sauce, that is the only endpoint that pastry is going to mock, right? Okay. Just to be sure that this thing is really working, what I'm going to do now is I'm going to hit a couple of enters here, and I'm going back to the window number 0. I clear my terminal, and then I will do curl http localhost 5000 /sauce for fries. And we have the ketchup. Now let's see what happens when I try a different thing. Let's say rice. Sauce name ketchup. And this is quite obvious because pastry is not implementing any business logic, is not actually doing anything smart. It's just emulating what the contract specifies. And the contract only gives me examples for fries. So it will always return ketchup. It's not accurate, but it works in terms of the structure. And the other thing important is that since we are using the validate request modifier, what happens if, for instance, I forget to include this parameter? It will give me a validation failure because the path for type is required in the query parameters. So it's not smart, I mean, it's not complex, but it's smart enough to help me validate my client, right? And the other thing is that I can see in the output when the requests were successful and when there was an error. Since the contract is not specifying what to do in the case of a 400, well, nothing happens. Nothing happens. But in the case of 200, it works. And that is what we need for now. Questions so far? Okay, let's move on back to the Windows 0. I'm going to clear my terminal again, and I will now run the tests. Damn it. Sauce. I run the test again, and notice that this time the tests are passing because my client, the client here, is requesting something at localhost 5000, and now we have a mock server responding to that port. So the tests are passing. This is good. TDD. So what we are going to do now, back to the window number 1, I'm going to open test suite.sh, which is our test recipe. I'm going to remove this line, and remember that test suite, as shown in the presentation, test suite.sh is located in the root folder. So if I'm going to run the test for the client, I need to first cd into sauce client, and from here I need to run pystry to boot up the mock server. I will sleep for 5 seconds just to give enough time to boot up, and this container will run as a daemon detached. Then I sleep for 5 seconds, and what I will do next is run my tests. Same thing as before. After I have run the test, I will do some cleanup, like this: docker stop, like this, and then back to the root folder. So again, test suite is located in the root folder. So I cd into source client, which is basically the same thing that I did here. I cd into source client. From there, I will lift up the mock server pystry, mapping the contract just as we did, validating the request, sleeping for 5 seconds to give enough time to boot up, and then I run my tests just as we did before. Nothing special, nothing different. And after that, I will stop. Stop all my containers and cd back into the root folder. I save. I go to the window number 2, and I will hit Ctrl+C to stop the container. I will close this window, and I'll be back to the window number 0. Here, I will cd back into the root folder, right? And I will do git status to see what has changed so far. Now, should I repeat any of the things that I showed so far before we move on? This is the time. Okay. So I'm going to do git add sauce client, which is the folder, and test suite.sh. Git commit --m. Okay, the Docker scenario. How I run the Python. Okay, so when you run Docker, to run the container, you need an image. The image is going to be pulled from this repository. This is Py3, which is our mock server. And we are going to do two things. pwd give us the current location. So I'm going to follow this same recipe. cd source client. So cd source client. In this folder, I have my contract. So I'll do this thing here. Right. First of all, pwd give us the current location, the current path, source client. So when I'm lifting my container, I will run map my volume. I mean, this modifier is for mapping volumes, which is the current path, source client, to this folder inside the container. I'm going to map this port, which is 5000 of my computer, my real computer, to the 5000 inside the container, so that every request that my computer receives to port 5000 will be redirected to 5000 inside the container. And the modifier that Py3 is going to receive is this one, for using this contract. And the other modifier is for validating the request. Okay? I'm going to close this window again. Okay, I added my changes, and now git commit -m adds client implementation. Clear the window and look, git push origin master. Run the container, sleeps for 5 seconds. Tests are passing. Isn't that wonderful? And now it's cleaning up. Stopping the containers. Yeah. Okay. Back to the presentation. What have we accomplished so far? We have implemented a client application emulating the server side using Py3, the mock server. We have implemented a contract from the consumer side point of view, and we have integrated contract testing from the consumer side in a continuous integration pipeline. This is a big win. Okay? Does anyone have questions so far? It's important if you don't understand anything that I just showed, please ask now, because we are going to move to the server side, and it's important to have this part clear. Sorry, repeat what part? Okay, we're gonna move on, and then we maybe in the Q&A session we can clarify things. Okay, now the producer side. The producer side will work as follows. We are going to use API testing, Sauce Labs API testing, to validate that the API producer is exercising the contract. It's basically the dark side of the moon. Okay. Let's start. So I'm going to close this for now. I will stay in the root folder, window number 0. I will clear my terminal to have everything clean. And what I'm going to do now is cd into the Sauce server. And what do we have here? We have Sauce server, TypeScript, the test, implementation, and the tunnel. So again, I'm going to open a new window, window number 1, as shown here, and I'm going to open the Sauce server, and I will open sauce.tests.typescript. Same thing, not exactly the same, but it's the same structure. But in this case, these are the tests for the backend. Is where I'm going to implement my business logic. So same thing here. In this case, this is not the implementation is not going to make HTTP request, just a plain function. So we don't need async here. So same here. The source for fries will be ketchup. I will follow the same process. This case is Dino test, but since I'm not going to access the network, I will just run it like this. Okay, we have a red test. Now we are going to make it green. So same thing as before, import sauce for from sauce.typescript. 10 seconds for what? Follow along, sorry. For questions, maybe I'm going too fast. Let's see the chat. Okay, good. So we will have the recording, yes. Okay, and now I'm going to open the sauce.typescript. Okay, same here. This is the template. The sauce for will receive the food of type string, right? And I'm going to connect to my database. And here I will have an entry for fries. And this will be ketchup. For rice, which I love, is the honey. And for nuggets, take a guess. What is the best sauce for nuggets? Barbecue mayo? No, it's actually Szechuan. Szechuan sauce is the best thing ever. Okay, so far, well, we have our database, super huge database, and we perform the query. So we send the food, and if by any chances, since the food might not be present in the database, I will default to ketchup. So if I send a food that doesn't exist, it will always return ketchup. Back to my terminal 0, I will run the test again. Boom, green. Make it red, make it green, make it clean. But there is no big thing that we can clean up here, so we will leave it as it is for now. Okay, the next step, since the tests are passing, I'm going to include these tests in the test suite. So again, test suite, and I'm going to testing the server. I will do cd sauce server, and once I'm in sauce server, I will just copy this line from the test. Okay. Back to my first terminal, I will clear. I cd back into the root folder. I check my repository, and I have changed the test, the server test, the implementation, and the test suite. So I will add those changes. Sauce server test suite .sh. Git commit -m. And what now? Obviously, we need to run our integration. Git push origin master. In the container, frontend is passing. Now it's cleaning up. And the backend is passing. Not all the backend. Yeah, exactly. Rick and Morty. Good, good. We have implemented only the business logic, but we are not yet exposing that business logic through an API, and that is the part that we are going to do right now. So, back in our window number 1, I'm going to open us server, right? And I have here my template. So what I'm going to do here is import my business logic source4 from source.script, right? I have my boilerplate. It will receive the URL, and from the URL, what is the parameter that I should retrieve from the search params? Who guess? Who take a guess? I'm waiting. What is the parameter that is mandatory? No. The query string parameter that is mandatory, that is should be there. 4. Exactly. And that will be my food name. So then I'm going to do the following. I will do declare a function, a constant called delicious sauce of type string, and that will be the result of querying my database for the given food. And what I'm going to do now is this. I will return a JSON with the delicious sauce, which is the delicious sauce that is coming from my database. So far, so good. Or does anyone have comments about my implementation? You have to be very attentive because I am deliberately including an error in this implementation. And we will see how it goes. So now I'm going to open a new window. I will cd into the sauce server. And here I will do dino run sauce server hello. because it needs to expose the port 8000. Now listen, what const food? Okay. So the food, it should be, okay, if the parameter is not there, we will default to fries. Back again to the window number 2. And what? Yes. Continue. Did not request net access. Lognet. Yes, it's running. So what I'm going to do now is do curl HTTP localhost 8000 sauce for, let's try with fries, and it should be ketchup. So it's working, but since this is exposing our business logic, in theory, if I pass something different like rice, it should give me the real deal, the thing from my database. So it's honey mustard. Let's try with nuggets. Szechuan, obviously. So this means that our server is indeed running in port 8000. So please follow along. What I did here was import the business logic, my business model, source4, from the source.typescript. And then here I retrieve the query string parameter, and I will default to fries. Then I perform my query to the database. And then I return a JSON with the property delicious sauce with the corresponding name that I retrieve from the database. Notice though that despite this application is a single file, we are implementing a model view controller application. Model, view, and this handler is the controller. Super simple. Okay, and to run the server, you just do pino run sauce server and then -- allow net to allow it to expose this port. Okay. Question so far? Okay. The next thing is to validate, to be sure that the server side is indeed implementing the contract. So since the application is running in our local host, we need to find a way to expose our local host to internet so that it can be accessible. I'm going to use Sauce Connect, but if you don't have Sauce Connect, you can use ngrok, or any other tunneling solution. So I will open the tunnel.yaml. If you guys are following along, which I hope, and you are in the US, please keep this line. If you guys are in Europe, keep this line. I'm going to keep the first one because I'm in Germany, so I will remove this one. For the user and the API key, let's go to Sauce Labs. You are going to log in again. Okay, and I'm going to API testing, and from my account in the top right corner, I go to settings, And here I have my username. So I'm going to copy, and I will put it here. Okay. And my key is down here. I'm gonna copy, and I will put it here. Please be kind with this information. I'm sharing this with educational purposes, but I will change them later. So, but in the meantime, please be nice. So what do we have? The URL, the user, the API key, and finally, I'm going to give an identifier for my tunnel, which is contract testing production. Okay, this is the configuration for my tunnel. Okay. Hopefully everyone is following along. I'm gonna open a new terminal, a new window, which is the number 3. And from here, I'm going to cd into Sauce server. And from here, I will do sauce connect space dash config tunnel.yaml. And hit enter. It's gonna take a while. In the meantime, questions, comments? Wrong query for API tunnel, I don't get you. For tunnel. Okay, Sangeet is taking care of it. Good. Okay, finally my tunnel is opened. That means that my local host 8000 is going to be accessible by from the internet. Okay, the next step will be as follows. Let me organize my notes here. Okay, I'm going back to window number 1, which is my editor, my IDE. And from here, I'm going to open the contract, which is one folder up in Sauce client, Sauce contract. And I'm going to include something here, since now I am wearing the hat of the backend developer, and I also have access to the contract. I am able to add some changes here. So I'll do servers, URL, localhost 8000. Okay, I changed the contract. Okay, let's wait a little bit. Another fast 30 seconds. Okay, now we have in the window number 3, the tunnel. Window number 2, the server. And we have just changed the contract reporting, including the server where the API is running. So I'm going to Sauce Labs and notice that since we are running the tunnel is shown here as active. So let's go to API testing. And in API testing, I'm going to import an OpenAPI file. Since I don't have any projects in my account, I'm going to create one. My first contract testing. Save. And this page, I'm going to import the contract. Then I browse to, what is it? Home. Again. Source recipe. Remember that the contract is in the client folder. Source contract. So you browse to the folder where you have the contract, open it, and then you select the location where you want to put the importing, and save. And here we have what the contract is describing. And notice that some of these fields are pre-filled with the examples that we provided in the contract. So the example for the for parameter is fries, and the example response would be ketchup with the source name. The server that we are running is localhost 8000, and that will just work because we are running a tunnel. So I'm going to generate a test for this. Testing producer side. Create test. Oopsie, there is no tunnel here. Tunnel. Please keep in mind the tunnel, because if you don't select the tunnel, localhost 8000 doesn't mean anything for API testing. So the tunnel should be selected here. And when we create the test, we have two things. The first one is the request, which is basically just making a query for the to the endpoint. The important thing here is this validation, the payload source, assert valid JSON schema. If I do double click, notice that what we are going to validate is that the response has a property called source name present of type string. Okay. Now I'm going to run the test to see what happens. And it fails. Why is failing? Who wants to guess? I'm going to open the report and I will show why. Oopsie. We'll see what is going on. Unexpected token 4 while compiling AF about Earth couple you made blah blah blah. We need to create an async function passed async true as an option. This is unexpected. But the thing is that for some reason, the server side is not implementing the contract. Okay, so what I'm going to do now is to check that the backend is implementing the contract as expected. So first of all, let me check one thing. For fries, if I send this request, oopsie, the tunnel, delicious sauce, ketchup, exactly. So why is not working? Well, this is strange. It shouldn't fail for this parameter, but it doesn't matter. Okay, what I'm going to do now is that here, since I'm trying to make this thing pass, I'm going to remove the strictness of this parameter, and I'm going to save, and I will upload the contract again. So I'll go to my tests, to my project, I go to my HTTP client, I will remove this import here, and I will import again. Source contract. Again, I will save in this location, and I will generate my test. Testing producer site version 3. And then I run. Let's see why it's failing this time. This is strange. Okay, let's move on. So the thing is that the error that I intentionally introduced in this process is that in the server, where is my server? Here, the response should not be delicious sauce, it should be sauce name. That is what the original requirement is specifying. Okay, so I'm going to save these changes. I will close this file. Then close the tunnel. Close the recipe. We have the business logic. We close the tests. And we finally close the contract. Yes. So what do we have here? So right now, what we are going to do is the following. We are going to save our changes, and we're going to push again. Git add source client, because we changed the contract, and source server with the tunnel and the details in the server API. Git commit adds API server. Git push origin master. Frontend is passing. And the backend is still passing, which is just our basic business logic. So what we are going to do now is a very interesting exercise, and is that we have accomplished so far. Let me go back to the presentation. Is that right now we have the API producer running in our local host. API testing is connecting to our API producer through a tunnel, and we have the contract upload to API testing. Our accomplishment is, well, we have the server side implemented, we have tested the contract from the producer side integrating SauceLab API testing, and we have a fully integrated contract testing workflow within our continuous integration pipeline. And what we are going to do now is, now that we have the fries and the ketchup, we are going to put the cherry on top, which is monitoring. So let's go back. Now that we have everything committed, I'm going back to my test. I'm going to remove this one here, just to clean this up a little bit and have a blank slate. I'm going to import my test, my contract once again. sorry, I'm going to also remove the previous import. And I will save this import here, just as in the previous step. I select my endpoint. I will create my test. I check the validation. Source name required true, yes. And I'm going to publish this test. Okay. So if I go back to my my project and go to my dashboard, which is where I'm going to monitor my executions, I have nothing here, not yet. So the first thing that I'm going to do is create a webhook to allow PyStream to send any report of executions in the front-end side to my dashboard. So I'll create a hook. And this will give me this URL. Okay. The next step will be this. Back to my terminal. I will open from the root folder the test suite.sh. In the line number 4, I'm going to split into a couple of more lines just to give more readability. And here I will do logger / insights events contract, and I will go to the beginning here before the path insights events contract. I will copy the URL and I will put it here before the path. Okay. And here I'm going to change this value to my access key. Remember, this access key is the same one we used in the tunnel. So I'll do source server tunnel, copy my key. I will put it here. With this, every time PyStream receives a request, it will send it to this webhook. And that request, the result will be shown in the dashboard. And the next thing, because it doesn't make any sense if we are using a continuous integration server for running a test, but then we need to go manually and run the contract test by hand. So we need to somehow automate that part. So that is what we are going to do now here. After we are testing, we test our business logic, we are going to do Docker run, remove the container after it's done, py.io, Sauce Labs, API CTL, run I tunnel and hook. So this is the test ID. So to retrieve this test ID, I go back to my project, my tests, and I will take this one, which is the one we just created when the contract was uploaded. So I copy the ID from here. Copy, back to the terminal, paste. The tunnel, I go to window number 3, which is where I have my tunnel running. Copy the ID and put it in here. And finally, the hook, which is the same one I have here. So I copy from here up to the hook ID, which is this one here. Notice that I'm skipping the insight / events, etc. copy, go to the end, paste, boom. Where is my parameter? Space. Okay. Questions so far? Let me check the session. Yeah, you're right, Alejandro. Sauce name is different from delicious sauce. That's okay. Oh, but actually, the I don't know for real. I don't know what is failing right now because the error message is complaining about the query string parameter, and that one should be working because it should have complained about the response, the body of the response, not the query string. And we are running out of time, so I don't have time to debug it right now, but we can figure it out later. But yes, you're right. That was the intentional error that I created. So going back to Sauce Labs, if I go again to my project and the dashboard, nothing is shown here. So after I have set my hook for sending the executions to report the results of requesting endpoints to PyStream and triggering using the CTL command to run this test from my continuous integration process through this tunnel, the results will be also posted to the same hook. So I will save my changes and close, check my repository, and I will add these changes. Add test suite.sh. Git commit -m adds API monitoring. And finally, git push origin master. Is running the front end, and now it's doing the cleanup process. Now the backend obviously is passing, and now we see this content here telling us that it is running the test that we specified in the recipe. It is running them in Sauce Labs, and we can see the reports here. Look, the front end is working, but the contract is not. So in one solution, we can test both sides of the equation, and we can easily be sure when something is passing, when something stops, is no longer passing, and we can proceed to debug. Okay. Okay. What have we accomplished? Well, okay. Do we have any questions? I'm going to exit this. Let's proceed with questions. No one. Well, okay, I suppose, guys, I'll give you 10 minutes back if there is no any questions or comments. The recording will be available soon, and also I'm going to push to the GitHub repository the full implementation ready to be tested using this continuous integration server that we run locally, so that you can just pull the repository again from GitHub and do the exercise yourselves using Sauce Labs API testing. My pleasure, Christopher and Sneha. Welcome. Yes, of course. I will upload a working version of this soon to the repository. You're welcome, Alejandro. Sangeet, are we done for today, or is anyone next? Do you have anything next?
No, this is the end of the API workshop. Like Julian said, we'll be sharing the recording as well as all materials following that as well, some instructions alongside the process that Julian had done live. If there are any questions, we will be around and moderating and such. So if you ask, they'll find their way to us, and we can definitely follow up afterwards. Yeah, otherwise everyone can have 8 minutes back and go check out some of the other sessions or get back to your day.
Goodbye, everyone.